In this video, I'm going to introduce us to this idea of these two different data types. So the reference data types and the value data types. And so a value data type actually holds a value while a reference data type refers to some data. And so this quote here from this website Code Maze, which you can look at if you click the link in this in the lecture notes here. So a value type variable directly contains its data and holds the data within its own memory location. On the other hand, a reference type variable stores a reference to their data, data which are objects. So it contains a pointer to another memory location that holds the real data. And so this idea of the pointer is sort of why I wanted to do this video before I get to, for instance, linked lists, because linked lists uses this idea of pointers, but we'll get there in a couple videos from now. So what this, the way you can kind of see this in the code is, so if we have two value types, val1 and val2, if I do the following, so whatever data type val1 is, I set that equal to some value, then I set val2 equal to val1. So val1 is copied over to val2. But then if I do this, so I make some change to val1, so say this is like an integer and I'm just adding +1 to it, then this will not actually change val2, because val2 just sort of takes a spot in the memory, and then in that spot in the memory, it takes a value, but that value just happens to be whatever the value of val1 was. However, if I have two reference types, so ref1 and ref2, and I do the following, so data type ref1 is equal to some object, so the object could be something like a class, and that's what I'm going to be using in this video. Then I do ref2 equals to ref1. So now ref2 is essentially a pointer to the same data, to the same object as ref1. And so if I do some change to ref1, this will also change ref2. And so we can actually look at that in the code here. And so for this video, I just have the code already up here, and I'm just going to uncomment out things as I go. And so I have here this type demo class where I have these two methods here. So this method, this value setter one, is essentially doing what I was talking about in the video for the value, where val1 I'm setting equal to this string here. So this is a string value. Then I set val2 equal to val1, and then val1 is equal to val1 plus this. So I'm appending this onto val1, and then here it will be printing these two things. And what we will see is that that val1 will have this appended to it here, where val2 will not. Whereas over here, I'm using this ref setter. So this is looking at references. And so I'm doing essentially what I showed in the presentation there. But so a few things to point out here that you might notice. So this method here has as its output a class object, where a class object is just this. So this is a class here, and so the class object is sort of an object you can think of that contains all of this. So every sort of object contains all of these things, and so we see that we can actually also take those as parameters, as inputs to this method. And so, I mean, it doesn't necessarily have to be the case that the input is the same as the output, but right here what we see is that I'm taking a class object as the parameter to this method, and then it is also the return type to it. And so what I'm doing is, so I have ref1 equals to this, so this input here, and so that is coming from this down here. So this is for those simple data types, so the string data types here. So I'm just instantiating the type demo class right up here, and then doing this value setter, which is just this method right here. Then all of this right here, so I'm instantiating the class object, which is this class right here. So I'm instantiating that right here. Then I'm taking the object dot name. So I'm taking the field, this name field right here, and I'm setting it equal to Alice. And so this is a string type field here. So I'm setting it equal to Alice. Then I am taking, so I'm making another object of class object type here that I'm calling type demo2, and I'm setting it equal to this ref setter here. So it's taking this type demo1 as an input, and it's making this type demo2 as an output. But so what we see up here that's sort of important. So ref1 is being set equal to this input. So it's the input. It's this object here, this type demo1 is the input. So it's setting this ref1 up here, which is a class object type right here, and it's setting it equal to that. Then I'm taking this ref2 up here and setting it equal to ref1. And so what you the important thing to notice is the order in which I am doing these two things here. So ref2 is being set equal to ref1. Then ref1 dot name, so it has this name field here. I am having equal to ref1 dot name, which was just the word Alice there. And then I am appending onto it, this is a person. So I'm doing that after I set ref2 equal to ref1. Then I'm outputting ref2. And so ref2 was set equal to ref1 before I did this appending here. And so then I am going to print the name for the ref2 here, which is this type demo2 here. And so what we will notice when I print this is that so we have these are the value types here. So remember we had this is a string data value, and then I appended onto it, and this is a change to val1. Val2 does not see that change. So if we look here, remember we set val2 equal to val1 before we changed val1, and val2 does not reflect that change. Whereas what we see for this one, so I set ref2 equal to ref1 before I made this change to it. This is a person added on to it, and then I print the ref2. And so we see that that actually is a person appended onto it, because these two things are sort of referring to the same object now, to the same data. So this ref1 so this right here, this ref2 equals ref1 is essentially saying that the pointer ref2 is now also pointing at the same data that ref1 is, instead of up here where we just sort of duplicated the val1 as another bit of memory called val2. These two things are now just pointing to the same data. And so that is sort of the difference you can see with the value and the reference type. And so if we continue on with this, so this is just sort of a hierarchy here. So C# data types, we have the value types in blue here and reference types in green. So for the value types, we have these simple types, which are these ones like the integral which is the int or integer, the floating point, character, boolean, so on. It also has enum types, struct types, and nullable types. I'm going to quickly discuss enum and struct types in this video. I won't really get into nullable types. For the reference types, we have class, interface, array, and delegate. In this video, I'm going to mostly, well, actually, I'm just only going to discuss class types. We'll get into things like interface types when I get into like abstraction and object-oriented programming and things like that. But for now, we'll just sort of focus on class types. All right, and so this idea of sort of referencing and then holding values has to do with what is called the stack memory and the heap memory. And I'm only going to very briefly introduce this. If you want a little more detail on this, these two links right here, which will be in the lecture notes linked to in the description down below, you can check those out. And so the stack keeps track of what is executing in the code, so what's been called. And so this is linear, like the order of the lines of code in the main method, where the heap keeps track of our objects, so the data used by the code, and it's non-linear. So it's the places in memory that are not necessarily next to each other. And so we have this sort of illustration here where the stack is sort of this linear structure here, where the heap are kind of all these little bits of data or objects just sort of in the memory there. And so in this stack we can have these pointers which point to objects in the heap. And so value types are held in the stack memory, where reference types are pointers to objects in the heap memory. And so this pointer right here would be sort of like what our reference is, and then it's pointing to some object here in the heap. So the main method is sort of like the stack, where each line of code is run one after the other going down the stack of code, where the other classes and methods being called in our main method are kind of like the heap, where it doesn't really matter where in the code we put them, because all that matters is the order in the main method in which they are being called. All right, and so just to kind of go into this a little bit more, so we have the value types, we have the simple types, which are, things like the integer, long, which are just the 64-bit integers, ulong, which are just long, but they are only positive numbers. We have decimal, character, and bool, and things like that. Enum, which I'm not going to get too much into in this, but they look like this. So you can put like a bunch of things into it like this, and so I actually have that here in the code, so I will uncomment that out. So we have this enum months, and so this is integer by default, and so it essentially just associates an integer with each one of these things in the enum. So each one will be given an integer starting from 0, but you can change them if you just set it equal to something in the code here. And so I actually have enum going on down here. I don't actually have any printout for it, but I'm just showing that you can well, actually I do have printout for it right here. So we can run this code, and what this part will do will print out like this, just the Jan part here. Then if we do this explicit cast int with the months.jan here, it will give us the integer associated with it. So if I run this code, we get this. So we see the printout. I have this, which is the Jan part, then the equals here as part of a string so that it prints out equals, then int months.jan, and that gives us the number associated with it. And so that is what that will actually print out. Then this, which doesn't have a printout, is just showing that you can make an array using this. And so this is just an integer array, and so I'm just casting the int in there. And so what we can also see is that if I do this, so take the months right there, and we'll just call this months equals new months, and I'll just put 1 in there. And so this is making an array of this type, so this months enum here. And so each element of that would have all of these things, and we could do sort of a months 0 equals months.jan. And so that's just a little bit about enums. Like I said, I'm not going to get too much into it here. Same with the struct types, so these structure types. So struct types are similar to classes, where we can have these properties and things like that. And so we can set these equal to things like Alice, or the int type to 4 and things like that. And so I do actually have that in here, so we can just sort of take a look at that. So this is a struct students, and so I just gave it a string name and int ID there. And so I will uncomment this out right here. So struct data type. So we have this students struct here, stu1, and then we can set things equal to Alice or this number and so forth. We can make arrays of these struct types, and so yeah, we could make this array with 3 elements here, and we just make each element here be equal to the students, and then we can use the indexes here to actually set names and ID numbers. So we have Alice with ID 8675309 and Bob here in index 1 with ID 3141593. And so we can do that with these struct types. And remember, these enum and struct types are value data types. So these struct type, like I said, is similar to classes, though they have less functionality, and they are stored in the stack instead of the heap. So those are the struct data types. So then we have the reference type here, which I've been talking about. So we use a class as a data type. And so in this little illustration here, we have public class houses. Then we could have all these different properties here. So a house could have an address, whether it's occupied, the number of occupants, the floor space, number of bedrooms, bathrooms, floors, and so on. Then sort of some pseudo code here, so we can instantiate or we can make an array here of this type with houses that has 4 elements in it, so it contains 4 instances of the class, and then we could run some code here that maybe puts some different values in for each of these things. But this is sort of how I think of that. So we end up with this array of instances of the houses class, each of which contains all the fields of the original class. And we can do this with lists, stacks, queues, dictionaries, and so on. But this is kind of how this 4 element array would look, where each element contains like a class here, and each of them have like their own sort of properties here. So the addresses and occupied bool here, occupants and everything could be different for the 0th index than it would be for the 1 index, for the 2 index, and for the 3 index here. So if we look at the code for this, so we already have that all uncommented out. So I'll uncomment out this stuff. So first I will uncomment out this. So we have the class data type. So this is the class object. So it's an array of these classes right here. So each one contains all of these fields and this method. So each element of this array contains its own set of those fields and its own printer method that we have up here. So this printer method up here, which will just print each of the name, age, and married on there. And so we set up this array here, and then we can do this, which for each element in this array, we are, well, at least for the first three elements. So we are setting the first name to Alice Allison. We're setting her age to 31 and setting married equal to false, and then we will print all that. And we'll do the same thing for these other two. So Bob Bobison and Carrie Carrison here, who have their own ages, their own marriage status, and so on. And so when we run this code, we get this. And so we see that this method here prints it out for each one. So we have Alice Allison, age 31, married, false. Bob Bobison, 22, married, true. Carrie Carrison, 30, false. And so it's just printing out each of those things. And then so what I have going on right here, which I will uncomment. So what I'm doing, so I have array class object. So I'm taking the third index of it and setting it equal to the 0th index of it. So the class in index 3 now also refers to the same data as in the class at index 0. And so then what I'm going to do is I'm going to take 0 and I'm going to change the name to Alice Carrison and married equal to true. So maybe we're saying Alice Allison here is marrying Carrie Carrison here. And so her marriage status is going from false to true. But then I am doing the printer for the third index here. And so remember, we set that equal to the 0th index before we made these changes here to the 0th index. But what we should see is that the changes will also be in the third index because this is a reference type. And so when I run this code, we get this. And so now this is printing the third index here, and it's going to reflect the changes we made to the 0th index because now we have Alice Harrison here, age 31, marriage true, because we set that the third one equal to the 0th one, so they're pointing to the same object. What you'll also notice, so it's not, the change is not up here yet because this is all happening after this first printout that we have up here on line 105, and so that does not have the change yet. But we see that since the 0th and the third index are pointing to the same thing, when we make a change to the 0th one, it also has the change in the third index of our array. All right, so another type that I'm not going to get into too much here, but just to make you aware that this is a type, are called anonymous types. And so it's a set of read-only properties. And so you use this var here, so this variable here, so anon, and so this is just the name of it, and then new, then we put in curly brackets, and you can put all these sort of different like name equals Dolores, age equals 51, married equals true, occupation equals doctor. And so here, so the anonymous types do become more important when we get to link or language integrated query, which will be a video down the line. But then we can look at some of the code for that here. So we have these anon types here, so I will uncomment that. So I'm making these three different anon types here. So we have Dolores, Doloresen, Eve, Evison, and Frank, Frankison, with their various ages, marriage status, and occupation. So I have this right here, and I have it commented out. So what this is showing, so we take a non-to dot occupation, so that's this field right here, and try to change it. So we can't actually change this because it's read only. So if I uncomment that out, we see that this throws up an error right here. So property or indexer for this cannot be assigned. It is read only. And so these are read only properties here. So I'll just re-comment that out. Then this code here, I'm just showing that we can make another anon data type here, and we are just putting these three anon data types up here into this other anon data type. And then so we have this right here, which I have commented out. So if I uncomment it out, so cannot operate on members of the anon set with a for each loop. And we see down here, so I can expand this up. This throws this sort of rather large looking error right here. So we can't use the for each loop for that. And so I will just re-comment that out. All right, so one last thing I wanted to discuss, and this is sort of what's the reason I put this video in here before the dictionary and hash table types, because this idea of boxing and unboxing will become important for that. And I'm only going to briefly introduce that here. Again, if you want a little more detail, you can go to this website here. And so essentially what boxing is, we turn a value type into a reference type. So it sends the value to the heap and leaves a pointer to it in the stack. And so that's what we have over here on the left. So we have this int value type 25. And then when we box it, we are sending it here to the heap and then just leaving a pointer to it here in the stack. Then unboxing is turning a reference type into a value type. And this must be explicit. So it brings the value type back into the stack, which is what we see over here on the right side in this figure right here. So we're taking this from the heap and sending it back to the stack. And so if we have this int value type and we set it equal to 25, then we have this object type equals value type. This is boxing, and it can be implicit. So we can just take object equal object type equals value type. And we don't have to do like an explicit cast. But then when we go back to int, we send it back into the stack, the unboxed value. We have to put this cast here. So this must be explicit using the int cast right there. So I have that in the code right here. So I will uncomment that right here. And so we have this int value type equal 25. We take object type equal value type. Then we can print that out here. And then we do the int unboxed value and send that right there. And so if I run this code, we get this. And so, I mean, it's just the same printout. It's just coming from different places. But we see that we have the int value, then we make it into an object. So we have the box value, and it still just gives us 25. But now it's a reference data type. But then when we unbox it, we send it back to an int, which is a value type, and then we can print that out here. But we just see that it's the same value. It's just sort of in different types of memory. And so this is boxing and unboxing, which, like I said, the reason I am doing this in a video sort of before I get to dictionaries and hash tables is that we will see that, well, I mean, kind of a spoiler here, what we'll see is that a dictionary does not do boxing and unboxing automatically, where a hash table is essentially just like a dictionary that can do this boxing and unboxing sort of automatically. But anyway, I don't want to get too ahead of us here. So yeah, this video, like I said, was about reference data types and value data types, where the value is sort of so it directly contains the data. It holds the data within its own memory location, where the reference just stores a reference or a pointer to the data. And these are sort of the types of value and reference data types. But anyway, I hope you found this video helpful, and I will see you in the next one.